Hello and welcome to Engineers Mindset Academy. Alright, so we've been doing a whole lot of series on Laplace transformation. So in this video, we're going to be picking some problems to explain all the concepts which we've learned in the previous 4 videos on Laplace transformation. Now let's consider the question on the board. It says, determine the Laplace transformation of the function f of t equals exponential minus 2t cosh2t. Alright, so first thing to do is to recall your Laplace transformation formula. The Laplace transformation of a function f of t, okay, is given as integral from 0 to infinity of that function f of t exponential minus st times dt. So this is the formula to evaluate the Laplace transformation of any given function. Alright, now in this case, the function f of t was given to us as exponential minus 2t cosh2t. Alright, so let's impute this function now into the equation. So we have Laplace of exponential minus 2t cosh 2t, and this is equal to integral from 0 to infinity. In place of f of t, we'll put in that exponential minus 2t cosh 2t multiply exponential minus st dt. So multiply exponential minus st dt. Alright, so this is equal to integral from 0 to infinity. Now from the law of indices, when you have two terms multiplying one another having the same base, you pick one of the term and add their powers. I have exponential minus 2t multiplying exponential minus st. So since both of them are multiplying one another and they have the same base, pick one of the exponentials and of course add up their powers. But then let's rearrange this equation now. We are going to have cosh 2t times exponential minus 2t times exponential minus st dt. So in this case now it becomes clearer. Therefore, this is equal to integral from 0 to infinity cosh 2t. Hence, you pick one of the exponential signs and then you add up their powers. You have minus 2t minus st, okay, multiplied by dt. Now, if you observe, t is common between the two, or minus t is common between the two, so you can actually factor out minus t. Therefore, this is equal to integral from 0 to infinity. This becomes cosh 2t exponential, okay, minus 2 plus s times t. So I can have something like this. Of course, minus is also common between them and t is common, multiplied by dt. You have this. Again, this is product integration, and I always say if you're encountering product integration, the best formula or the only formula to use to evaluate product integration is simply integration by parts. From the formula, integral of u dv is equal to uv minus integral of v du. This is the integration by parts formula. So you select u to be the given function. Okay, u be the given function that was given to you in the equation. Now the function in this case is exponential minus 2t cosh2t, but notice that after evaluation, this exponential is now merged with what the exponential in the Laplace transformation, exponential minus st. For that reason, cosh2t is going to be chosen as u. That will become, because I still have it as my given function. So let u always be your given function. In this case, cosh2t, and dv becomes this exponential function in the integral. All right, so you simply say let u be equal to cosh 2t, and dv is now going to be the exponential function there, which is exponential minus 2 plus s times t multiplied by dt. All right, so if you look from the equation, u dv is equal to uv minus integral of v du. So which means we need to find what du is. We also need to find what v is. Now we have dv, hence we need to find v. We have u, we need to find du. To find du, simply what? Differentiate u. Okay, so we simply differentiate u to find du. And u is given as cosh2t, and I've always said to differentiate a trigonometric function, the first thing to do is to differentiate the angle in front of the trig function. use this derivative to multiply the derivative of the 3 function itself. The angle in front of this 3 function now is 2t. If I differentiate 2t, I'm simply going to have what? 2. You keep this aside. Now, the 3 function there is cosh, hyperbolic cosine. Okay, so if you differentiate hyperbolic cosine, please mind you, you're not going to have negative sign. No. If you differentiate hyperbolic cosine, you're still going to have what? A positive hyperbolic sign. So if I differentiate cosh, I'm simply going to have sine. Then put back your angle. The angle there is 2t. Now, because you differentiated a function with respect to t, you simply append the t to it. Hence, the u becomes 2 sine 2t dt. This becomes our du. Alright. Then to get v, we simply integrate the exponential function. V is obtained by integrating the v. So which means we're actually what? Integrating this function, exponential minus 2 plus x times t dt. So we're actually integrating that function. And I've said to integrate an exponential function, the shortcut is simply differentiate the power of the exponential function, use the derivative to divide the exponential function itself. That's how to integrate an exponential function. Now, the power of the exponential function there is minus 2 plus s multiplied by t. This is the power of the exponential function. We want to integrate this. Now, to integrate an exponential function, you differentiate the power. If I differentiate this power with respect to t, I will be left with what? Minus 2 plus s. This is what I'm going to have left, because t here is to the power of 1, so I'll be left with this. Then use this variable now, this value, to divide the exponential function itself. The exponential function remains exponential minus 2 plus s times t. Now, once you divide this by minus 2 plus s, then this becomes what? The integral we're talking about. So to integrate an exponential function, differentiate the power, use that derivative to divide the exponential function itself. You have the integral. So this simply implies that v is equal to, simply, I can move this negative sign up now. It becomes minus exponential minus 2 plus s multiplied by t all over 2 plus s. So this becomes my v. Alright. Now, having found this, we can now substitute into the integration by parts formula. Integral of u dv. So we have integral u dv is equal to, so we said it is u multiplied by v. Now, what is u? We said let u be cosh2t. So you have cosh 2t multiplied by v. What is v? V is simply this, minus exponential minus 2 plus s all over 2 plus s, okay, minus integral of v du. Again, v remains minus exponential minus 2 plus s, okay, times t, please, times t here, all over 2 plus s multiplied by du. What is du? Du is 2 sine 2t dt. So multiply by 2 sine 2t times dt. We have this. So let's rearrange this now. Integral of u dv is now equal to, rearranging this, now I'm going to have minus exponential minus 2 plus s times t, okay, cosh 2t all over 2 plus s, okay. And here observe minus times minus becomes plus, and then 2 is a constant, 2 plus s under here is also a constant, so you can pull them out of the integral sign. You have something like 2 all over 2 plus s integral of, okay, rearranging this as well, it becomes sine 2t exponential minus 2 plus s t times dt. So we simply have this. Now, this shows we are having integral of sine 2t exponential minus 2 plus st dt. It means we still have to what? Integrate this function again. And since this is a multiplication of two functions, it means we have to carry it out again by parts. So we still need to integrate this part of the equation again by parts. Alright, so let's do it and see. So let's call this equation 1. Then let's pull out this particular integral and integrate it separately, then bring it back and plug into this equation 1. The integral is simply integral of sine 2t exponential minus 2 plus s t times dt. This is the integral. So let's integrate this specially or separately. The same principle, since they are product of integration, the same principle holds. We say let u be sine 2t always, and dv remains the exponential function. Dv equals exponential minus 2 plus s multiplied by t. Always dv remains this times dt. Dv always remains this. Okay. So if we have this now, we know the formula for integration by parts is still going to be this formula. So all we need to do is what? Find du and of course find v. And we know that even if we find v, we're still going to be obtaining the same result as we obtained there, because the v is always going to be the exponential function. So let's find the u now. We're given that u is equal to sine 2t. To differentiate or find the u, remember, first of all, you differentiate the angle. The angle is 2t. If I differentiate 2t, I'm simply going to have 2. Use the derivative to multiply the derivative of sine. If I differentiate sine, I'm going to have cosh. Put back your angle 2t. Now remember, since I'm differentiating with respect to t, always append times dt. So that's the u. V also remains the integral of the v. And integral of the v, from here we have v to be equal to this. Okay, and if we integrate the v, we're still going to have v to be what? This. All right, so we pull it back. Our v is simply what? Minus exponential minus 2 plus s times t all over 2 plus s. So this remains our v. So let's plug back into the integration by parts formula. Mind you, we're integrating sine 2t exponential minus 2 plus s t, okay, times dt. So this is equal to, remember, u times v. And what is u? U is equal to sine 2t. So we'll have sine 2t multiplied by v. What is v? V is simply this, minus exponential minus 2 plus s all over 2 plus s minus integral, okay, so I'll put it down here, minus integral of v du. V remains exponential minus 2 plus s all over 2 plus s times du. And du gave us here 2 cos 2t dt. So we'll have 2 cos 2t times dt. We have this. So integral of sine 2t exponential minus 2 plus s t dt is now equal to, let's rearrange the equation now. We are going to have minus exponential minus 2 plus st sine 2t all over 2 plus s, okay, minus, okay, now observe here, please. Observe here, minus times minus becomes plus. So this is now plus. Again, I have 2 as a constant. I have 2 plus s here as a constant. So you can put them out. It becomes 2 all over 2 plus s integral of cosh 2t exponential minus 2 plus s times dt. So the integral of sine 2t exponential minus 2 plus s t times dt is simply given as, okay, as this. We simply obtain this as a result. So since we know this now, we can substitute this into equation 1. Okay, put this into equation 1 in place of this integral. So in place of this, we are going to be putting in that value. We can do that over here. All right, so we have integral of u dv to now be equal to, we have here minus exponential minus 2 plus s cos 2t all over 2 plus s, okay, plus 2 all over 2 plus x plus 2 over 2 plus s into this integral, but we now have a value for this integral of sine 2t exponential minus 2 plus st dt. We obtain the value to be this. So we plug in this value now into this equation in place of this integral. We have minus exponential minus 2 plus st sine 2t all over 2 plus s, okay, plus, not forgetting, plus 2 all over 2 plus s plus 2 over 2 plus s integral of cosh 2t exponential minus 2 plus s t times dt. You have this. Okay, at this point, let's expand the bracket with 2 all over 2 plus x. And while doing that as well, let's also involve or include all the notations and their symbols. This is integral u. What is u? Remember at first, when we said integration, we said let u be equal to cos 2t. I think I've wiped it. But then we said let u be equal to cos 2t and let dv be equal to exponential minus 2 plus st dt. So let's plug in these values back into the equation because this is what we were integrating earlier. So in place of u is cos 2t and dv is exponential minus 2 plus st times dt. This is what we were integrating earlier. And this is now equal to minus exponential minus 2 plus st, okay, cos 2t all over 2 plus s. Now we can expand this bracket with 2 over 2 plus s. Notice that there's minus here and this is plus, so minus times plus becomes minus 2 times the numerator, 2 plus s over here multiplied by the denominator here. So we have 2 exponential minus 2 plus st sine 2t all over 2 plus s multiplies 2 plus s here. I'm going to have 2 plus s all squared. Same thing now, expand this other integral sign now with 2 over 2 plus s. So 2 times 2 gives us plus 4. 2 plus s times 2 plus s here gives us all over 2 plus s all squared integral of cos 2t exponential minus 2 plus s t times dt. All right. So we can wipe here now. Now, a very careful observation shows that at the left, we are actually looking for integral of cos 2t exponential minus 2 plus st dt, and we are still seeing the same results at the right, integral of cos 2t exponential minus 2 plus st dt. So, and this is what we're looking for. So instead of going further to integrate this, all we need to do at this point is pull this towards collecting like terms to meet this man over here. So it's more or less just integrating twice. After integrating twice, the both terms will fall back to themselves. Okay, so what you're having on the left hand side, which is what you're actually looking for, the integral you're looking for, you're going to be seeing it appearing on the right hand side. Instead of further integration, you pull this back to meet this man, okay, by collecting like terms. So at this point, you simply collect like terms. Since this and this looks alike, you simply collect like terms. And if you do that, you put this down, you have integral of cos 2t exponential minus 2 plus s t times dt. Now, if I'm pulling plus 2 over plus 4 over 2 plus x all squared of this integral over here, positive sign, cross and equal to sign becomes negative. This becomes minus 4 over 2 plus s all squared integral of cos 2t exponential minus 2 plus st multiplied by dt. And this is equal to everything we have here, minus exponential minus 2 plus st cos 2t all over 2 plus s minus 2 e minus 2 plus st sine 2t all over 2 plus s all squared. Okay, so we have this. All right, so at this point, this integral is common among themselves, so we can factor. So we simply factorize at this point. Factor one of them, it becomes integral of cosh 2t exponential minus 2 plus st times dt into 1 minus 4 all over 2 plus s all squared. Okay, so we have this. And this is equal to everything we have here, minus exponential minus 2 plus st cosh 2t all over 2 plus s. We'll keep this aside, minus 2 exponential minus 2 plus st sine 2t all over 2 plus s all squared. Okay, at this point, we can simply take LCM between these terms in the brackets. I have 1 minus 4 over 2 plus s all squared. Now, this one can be written as 1 divided by 1. We can have something like this. This one can be written as 1 divided by 1. So you take the LCM. The LCM is 2 plus s all squared. So you pick the LCM, which is 2 plus s all squared. So 2 plus s all squared divides by 1 remains 2 plus s all squared. Multiplied by 1 here becomes 2 plus s all squared minus 2 plus s all squared goes into 2 plus s all squared is 1. 1 times 4 gives you 4. So you have this. So you might want to expand this, or you might also choose to leave it like this. But I think leaving it like this would be the best for me. All right, so that is simply rearranging what we have there. This becomes integral of cosh 2t exponential minus 2 plus s c dt, multiplying now by, this becomes this, 2 plus s, okay, all squared minus 4 all over 2 plus s all squared. So we have this. All right, so the whole of this is equal to minus exponential minus 2 plus st cosh 2t all over 2 plus s minus 2 exponential minus 2 plus s t sine 2t all over 2 plus s all squared. We have this. Now, we are looking for this integral, which means we need to divide both sides by this term in the brackets. Since we are looking for integral of course 2t exponential minus 2 plus st dt, then we simply divide both sides by what? This term in the bracket. So this remains alone, which is what we are looking for. And if you carry out this division, I've said in the previous videos, if you carry out this division, the order of this will change when it gets over here. The denominator will move up, and whereas the numerator will move down when it moves over here after division. All right, so let's do the division over here. All right, so integral of cosh 2t exponential minus 2 plus s t dt. Now after division, like I said, 2 plus x squared comes up. I'm going to have 2 plus s all squared all over 2 plus s all squared minus 4. So this actually happens multiplying by the whole of this after division. So we have minus exponential minus 2 plus s times t cos 2t all over 2 plus s, okay, minus 2 exponential minus 2 plus st sine 2t all over 2 plus s all squared. We have this. All right, so at this juncture, we can expand with the brackets. expand, okay, this bracket using every term over here. So we're going to have integral of cosh 2t exponential minus 2 plus s t times dt to now be equal to, now expand this bracket, observe if this multiplied by this first term, I have 2 plus s under here, I have 2 plus s all squared here. That means this will cancel one of these. So at the numerator, I'm now left with 2 plus s only, multiplying this term. Then denominator remains this. So that means if this multiplies this, I'm going to have minus 2 plus s multiplying exponential minus 2 plus st cosh 2t all over the denominator 2 plus s all squared minus 4. Same thing happens here. If this term now multiplies this term, I have 2 plus s all squared under here. That means this will cancel this. This will cancel this 2 plus s all squared. So which means I'm only left with this term at the denominator. So for here, I have minus 2 exponential minus 2 plus s times t shine 2t all over, denominator becomes now 2 plus s all squared minus 4. I have it. So this is now my integral. I have gotten the integral, but this is not my Laplace transformation. Remember, the Laplace transformation of this constant must always be between 0 towards infinity. So if I effect this limit, then this becomes the Laplace transformation of this function. Hence, I have to effect the limit by putting in what? Looking for the values at the limit 0 to infinity. So the upper limit is infinity, lower limit is 0. Therefore, the integral from 0 to infinity of the function cosh 2t exponential minus 2 plus st dt is now equal to, so let's start with the upper limit, infinity. Wherever you see t, put in the value as infinity. So I have here minus 2 plus s exponential. Okay, now this is exponential minus 2 plus s times t, and t now stands for the upper limit. The upper limit is infinity, so we simply put minus infinity times 2 plus s. Okay, all okay, cosh 2t, so cosh 2 in place of t is infinity, so it becomes cosh infinity times 2 all over 2 plus s all squared minus 4 minus 2 exponential, same thing here, minus 2 plus st, there's t here, so in place of t, we'll put in infinity, so we'll have minus infinity times 2 plus s shine, I have shine 2t over there, but t now is infinity, so it becomes shine infinity times 2 all over 2 plus s all squared minus 4. So this is the upper limit. Now upper limit minus the lower limit. The lower limit is 0. So wherever you see t now, put the value as 0. So we'll fall back into the equation. I have here minus 2 plus s exponential. Now this is exponential minus 2 plus s times t. If t is 0, 0 times 2 plus s becomes 0. So automatically everything here becomes exponential 0. Cos 2t, t is 0, 2 times 0 becomes 0. So this becomes cos 0. Cos 0 all over, I have 2 plus s all squared minus 4. Okay, so this is the, for this case, so we have here minus 2 exponential minus 2, okay, minus 2 exponential. Now t is 0 as well, lower limit, 0 times everything here becomes 0, so it becomes exponential 0 shine 2t, t again is 0, 2 times 0 becomes 0, so I have shine 0 all over 2 plus s all squared minus 4. All right, so we have this. Now, exponential to infinity is undefined. Hyperbolic cos to infinity, which is cos infinity, is also undefined. Automatically, everything here becomes 0. Same thing, exponential to infinity is undefined. Hyperbolic sine to infinity is also undefined, so everything here becomes 0. So we simply have that integral from 0 to infinity of cos 2t exponential minus 2 plus st dt is now equal to, everything here give us what? 0. Okay, so upper limit is 0 minus lower limit. Now let's evaluate lower limit. Lower limit we have exponential 0 is 1, cosh 0 is also 1. So 1 times minus 2 plus s here gives us minus 2 plus s all over 2 plus s all squared minus 4. That is for this part. Okay, this minus exponential 0 here is 1, but sine 0 is 0, so which means automatically everything here becomes 0. Hence, we have this all over 0. Okay, so 0 minus minus, so minus times minus becomes plus. This is now equal to 2 plus s all over 2 plus s all squared minus 4. Hence, the Laplace transformation of that function, therefore, the Laplace transformation of exponential minus 2t cosh 2t is equal to 2 plus s all over 2 plus s all squared minus 4. That becomes the final answer to that particular problem. All right, guys, so I hope this video actually explains Laplace transformation better. In the next video, of course, we'll come up with another example to properly explain the concept of Laplace transformation. I will see you in the next video. Thanks and cheers.